Alright, here's our video today. P and S waves, seismic waves during an earthquake. And we'll talk about the P wave, the S wave, and of course there's also surface waves, which we'll talk about. So let's get my pen ready. So seismic waves, they're energy waves. So we should put a little arrow there and say they're energy waves caused by earthquakes. And the word seismic is a Greek word. It comes from the Greek word seismos. Seismos. And it just means shock. Seismos. So just briefly, and then we'll go over it more, there is the primary wave, and guess what that is? The P wave. The primary, the first. The primary wave. It's the first to arrive at the scene. And of course the S wave is the secondary, the second to arrive. Secondary, second to arrive. And then of course, I said we do have surface waves that they're the third to arrive, right? So let's just we'll talk about how these waves occur. But first, I think we should talk about earthquakes, right? I think we all know what an earthquake is. Well, an earthquake occurs when there is stress building up along a fault. And there are many faults, but in this video we'll just talk about a normal fault. Just a normal fault as opposed to abnormal. No, there's no abnormal faults, but they call it the normal fault, and what is happening is the crust is shifted down. So let's look at a picture of that. And if you're wondering, a fault is really just a crack in Earth's crust. There's a crack, and not a little dinky crack, but we're talking about a crack that could be 5 miles or more into the crust. So here's just a picture, right? And we can see here's the fault plane right over here. And in a normal fault, we see a shift. There's stress in the fault plane, and there's a shift where the crust right over here, the surface of land shifts down. See how it's going down. And as it goes down, they call the crust moving down the hanging wall, and it's moving down by the foot wall. There's 2 vocabulary words there. Foot wall, hanging wall. So there it is, if you want to look at it for a few seconds. Notice the house should have another window maybe. Perhaps we should put another window there. Bigger window. Look out. So these faults are caused by tectonic plates, the normal faults. And tectonic plates are moving. They're always moving. And let's get an example of that. So here we are. You see North America. You will see the Pacific plate right over here. This Pacific plate is running right into the North American plate. And of course they will move. And as they move, they build up stress. And if the stress gets too intense, of course, it could cause a earthquake, which happens a lot in California. Let's zoom in on California. So you can see the San Andreas Fault over here runs down through California here. See, it's running right into San Francisco. And we'll talk about an earthquake that happened in San Francisco in 1989. It's called the World Series earthquake. And you can imagine, you can think that it happened during the World Series. Now this earthquake was a 6.9 magnitude. And it happened on October 17th. Don't have to put the comma there. 1989. Should put the comma here, right? Don't tell the ELA teacher. So it was Game 3, in case any history buffs out there. Game 3 of the World Series between the Giants playing in San Francisco and their crosstown rivals, the Oakland A's. Well, they used to be the Oakland A's. Now they're going to be the Las Vegas A's. Athletics, A's athletics. And so this occurred about 56 miles south of San Francisco. So let's look at that. Let me write that down. 56 miles south, what they call the Santa Cruz Mountains. That's where the earthquake's epicenter was, where it occurred. So, okay, let me get a picture of that for you. So, here's San Francisco, and it happened in Candlestick Park. It used to be the home of the Giants when they moved out to San Francisco in 1958, but it's about around here somewhere, maybe up a little more. So, and here is the mountains over there. And so what we call this, when you're looking at it, there is an epicenter, and that's the center on the surface. Of course, it happens below the surface, and that's called the focus. So the focus is where it occurs, and the epicenter is where the waves are radiating out from. And I should say not all the waves, but that's where the most harmful waves, not rays, that's where the surface waves start, the surface waves. Because from the focus we got going out in all directions, we have, again, the P and the S waves, again, primary and secondary waves. By the way, Candlestick Park closed and demolished in 2015, so it's not around anymore. And by the way, another thing about Candlestick Park is the Beatles, if you're into the Beatles, it was their final performance, well, paid performance, in 1966, because they did have a performance on the rooftop, the famous rooftop picture, later on. So, again, with the P waves, in this, when the earthquake occurred, the P waves were traveling pretty fast. So the P waves are the fastest, and they compress, it's compressed energy. So the P waves took about 15 seconds. It took about 15 seconds to reach Candlestick or San Francisco. So and if you're thinking about how they were going 5 miles per second. That's how far they were going, and that's 18,000 miles per hour. So they are going fast. P waves, again, are the fastest waves and the first to arrive. And I'll talk about how that energy is created in a minute. So if you look at the P wave, again, the primary wave, it's moving, the wave is moving in a literal direction, right? It's moving straight, right? It's moving in one way like this. Whereas you see the secondary wave kind of goes up and down. It's moving up and down like this, almost like a sine wave. And so what happens to the material, P waves can go through, by the way, solids, because the nature of the wave, they can go through solids, they can go through gas, they can go through liquid. S waves, by the way, can only go through solids because they're looking at shear waves. They're shear waves, which I'll explain. They're looking at shear, write this down over here, shear deformation. I'll explain that. So in simple terms, the P waves, as they're moving, as the wave is moving, the material in the earth is being compressed. Think of a slinky. It's being compressed and expanded. Compressed and expanding. That's what's happening to the material. But in an S wave, and by the way, they happen at the same time. Once the earthquake happens, they're happening at the same time. It's just the P wave gets there first. The S wave, as you see, it's moving up and down. The material is also going perpendicular. It's going up and down also. So you can think of it as the wave moving this way, but going up and down, and the material going perpendicular to it, up and down. And so that's shear deformation, and that needs a solid medium. Whereas P waves, they don't need that. They can go through gas and solids and liquids. And let me just clear that out for you. Clear it all. There it is, so you can just get a picture if you need to. Again, think of the slinky. See how the wave is traveling. See how the wave is traveling with the S wave. And again, as these waves hit the surface, there's now surface waves. And the surface waves are the most violent. That's where you get that shaking, that rolling. The P waves aren't as violent. So the people in Candlestick Park, let's get a picture of that. And here's Candlestick Park. And Again, the Giants moved to California in '58, but they didn't move into Candlestick until 1960, if you care. Also, it was a very windy park, very chilly. Wasn't really. It was built specifically for the Giants, but a lot of players did not like playing there. Anyway, let's pretend now that here we are in 1989 at the World Series, the Giants versus the A's. So the first waves to come again would be the what? The P waves. You got it. So when the P waves came 15 seconds from the focus, remember the focus is the below the surface of the epicenter, the people in the stadium would have felt some slight vibrations. Like, hey, what's going on? Of course, people living in California would probably say, oh, it's an earthquake coming. So the P waves, we would say they had slight vibrations. Then, maybe 5 seconds later, the S waves show up. Even though they're slower, they're more intense, so there's more shaking, more vibrations. And again, this is happening pretty quickly. And then, of course, when those P waves and S waves hit the surface, then the surface waves come. And then you know, hey, there's something going on, because there is violent shaking, violent vibrations. Now, the good thing, and we're talking, the S waves probably came 30 seconds after the P waves. So it was very quick. So the Candlestick Park, by the way, it suffered, there was not really that much damage. There was some cracks, but everybody was safe. They felt the violent vibrations, but it held up well. All right, and here we have a chart. We can see the earthquake P and S waves, travel time. You see the dependent variable is the travel time, and the independent variable is the epicenter distance. And you can see just by reading the chart, right, the P waves arrived. You can say right here, this is the travel time. Took them, well, this is not the Oakland A's Giant World Series, but this is just a general graph. So in this graph, it took the P wave 10 seconds to travel 6.5 kilometers. Whereas the S wave, it took longer, it took 18 seconds. So you can see these different types of waves. So remember again, just to review, the P waves are first, they're faster, less energy, and they can go through gas, liquid, and solid. Remember that. Where the S waves are slower, but they have more energy, but they can only travel through solids. All right, so that's our video today.